Hello and welcome to our Senior Design Project presentation. We were tasked to design a roundabout system for the State Route 67 and Highland Valley Road intersection. We are Group 3 Velociraptor Engineering, and we are a bite above the competition. My name is Joe Iacovera. I was the project manager for Velociraptor Engineering. I'm a construction engineering major, and I worked on the constructability and drainage modeling for this project.
My name is Shannon Lewis, and I am the environmental engineer for this project.
My name is Gerald Chacon, and I am one of the 3 civil engineers on this project, focusing on the traffic analysis.
I'm Jose Mendez. I'm a civil engineer major and worked on the geotech and CAD design.
My name is Ernesto Quintero, a member of the Velociraptor team. As a civil engineer, I assisted in the AutoCAD drawing and the design phase of the roundabout.
The existing site shown here is a 4-way signalized intersection with no designated bike path on either State Route 67 or Highland Valley Road, and with unsafe pedestrian crossings. The intersection suffers from poor drainage outlets that can leave large puddles of water on the roadway, which can make the roadway unsafe. During peak hours, this intersection suffers from high amounts of traffic that can stretch 3 miles away from the intersection. Currently, the traffic signals cannot cope with the amount of traffic during peak hours. Here are the average daily traffic values provided by SANDAG. Using these ADT values from 2010 and the population growth of the City of San Diego from 2010 to 2020, we are able to calculate a future ADT value for 2020. A previous study was done on the same intersection that concluded that the intersection operates at a level of service F during peak hours. We will be using these values as the basis of our proposed roundabout design.
The primary objectives of our design consist of improving the current flow of traffic and decreasing the amount of queuing on Interstate 67 and Highland Valley Road. By introducing a roundabout, we are not only incrementing flow and decreasing queuing, but also we are creating a safer commute for all users, drivers, bicyclists, and pedestrians. Situation that did not previously exist and that may help local economy in the future by creating an appealing site for population growth. Furthermore, the design provides adequate signs, lighting, and a new drainage system, which reinforces the fact that this design allows for a safer and much more pleasant commute through the area.
As you can see on table 623.1a, we will need an R value to determine our subgrade type. Our R value was determined to be 20 by Rick Larson, a geotechnical engineer for AMEC Foster Wheeler. As you can see in the table, this corresponds to subgrade type 2. We will use this subgrade type in figure 623.1. Our climate region for this project is low mountain, and you pair that up with type 2 and you have to use table 623.1k. All design considerations can be found in the Highway Design Manual, section 405.10 of the roundabout section. Next, I'll be going over CAD design. Some of our objectives were to reduce traffic and improve safety. Our current level of service is F for both evening and morning. After the roundabout is constructed, our level of service will be B for the morning and level of service C for the evening. Some of the design considerations that need to be observed in the roundabout are bike pathway usage, entry speed, pedestrian pathways, transit use, central island, and splitter islands. Bicyclists may choose to travel in the circular roadway of a roundabout by taking a lane, while others may decide to travel using the bike lane. Therefore, the approach and circular roadways as well as the bike lane all need to be designed for the mobility needs of the bicyclists. The next design consideration is entry speeds. Lowering the speed of vehicles entering and traveling through the roundabout is a primary design objective that is achieved by approach alignment and entry geometry. For our multi-lane roundabout, our entry speed will be 30 miles per hour, which will be achievable.
The proposed roundabout design brings the removal of traffic signals, which will improve the efficiency of traffic flow due to the constant movement of drivers. The entry speed will have to be lowered to 30 miles per hour in order to create a smooth transition from incoming 55 mile per hour traffic into the roundabout. Warning signs will be placed prior to entering the roundabout, which will urge drivers to slow down upon entering. Signing and striping for pedestrian crosswalks will warn drivers of pedestrian crossing and increase their safety. Designated bike lanes allow bicyclists to have a separate lane from traffic for their mode of transportation. Due to the placement of the roundabout, this will allow us to purchase only 2 parcels of land rather than 4 for our right-of-way acquisition.
Roundabout constructability. The estimated materials costs for this project are around $900,000. This estimate includes costs of roadway materials, relocation of existing power lines, signage, drainage, and grading. Unit prices were obtained from County of San Diego Department of Public Works Land Development Unit Price List approved June 2014. This estimate does not include land procurement costs, time and labor costs, unknown soil conditions, and permitting costs. Traffic mitigation. Project phasing is used to maintain traffic flow during peak hours. State Route 67 shall remain open as long as possible while site preparations are made around surrounding areas. Local roadways will need to be completed to create detour paths when necessary. Work done during non-peak hours or at night. High noise producing work such as demolition is performed during the day because of local residents in the area. Existing drainage on site. At present, the roadway is currently poorly graded and has low spots in the middle of the intersection. These low spots create puddling conditions which are very unsafe to drive by. To rectify the situation, our design includes grading that slopes all existing watersheds to the middle of the intersection, where a drain is located to expel any water. This creates a much safer environment for commuters.
As with any construction project, negative environmental impacts can occur. These impacts include negative biological effects on plant and wildlife species and habitats, loss of soil resources and vegetation, groundwater pollution, noise pollution, and air pollution. The potential sensitive species and habitats that can occur at the site location include non-native grassland and protected wildlife and plant species. Non-native grassland is a sensitive wildlife habitat that does occur at the site location. Protected wildlife species, including 2 endangered species, can occur at the site location. 22 sensitive wildlife species have a low potential to occur. 7 have a moderate potential to occur, and 3 have a high potential to occur. The white-tailed kite is a sensitive wildlife species that has been observed on the site location. Protected plant species, including 1 endangered and 1 threatened species, can occur at the site location as well. 8 sensitive plant species have a low potential to occur. Velociraptor Engineering believes that the environment is a top priority. Mitigation measures have been planned and are required by CIVE, the California Environmental Quality Act. These measures will minimize or eliminate any negative environmental effects. Negative biological effects and the loss of soil resources and vegetation will be mitigated by replacing or providing substitute habitats in land and vegetative resources for any that are compromised. Groundwater pollution will be prevented by ensuring the proper collection and disposal of oil and lubricants during construction. Also, septic tanks or pit latrines used during construction will be located far away from groundwater aquifers. Noise pollution will be reduced by ensuring that vehicles and construction equipment are fitted with proper mufflers. Construction workers will use hearing protection when noise reaches above 85 dBA. Finally, construction will be limited to daytime and completed quickly. Air pollution will be minimized by spraying water on site during construction to mitigate the escape of dust particles.
In conclusion, our roundabout will set up improved safety conditions for pedestrians, cyclists, and commuters in the area. Pedestrian crossings and walkways will be set up. Bike lanes for cyclists will be introduced, and improved drainage conditions will reduce hazards during raining conditions. In addition, traffic flow through the area during peak hours will be improved, and there will be no longer a 3-mile backup all the way to Mount Woodson. In addition, there will be lower maintenance costs for the intersection due to the fact there will be no traffic signals to maintain. I hope you enjoyed our presentation and have a great day.